Okay. So, oh yeah, go for it. I don't know if any of them work though. Try one. So write the simplified expression the same as the beginning expression. So as we're simplifying radical expressions, you're going to notice that the end result, sometimes you're going to start with an exponent that is to a fractional power, and sometimes you're going to start with a root, and you're going to make sure you leave your answer the same way that it started, okay? So the main thing you need to know is your final answer should have no negative exponents, no exponents that are not positive integers in the denominator, not a complex fraction, and the index of the remaining radicals is at least the least number possible, as in like you reduce the fraction. All right. So we're going to convert exponential fractions or fractional exponents into radicals and then vice versa. So let me show you how we do that. So step one is you're going to draw yourself a little radical symbol, okay, like this. And then whatever the variable is or the number is going to go on the inside. Whatever the numerator of your fraction is going to be the power on the inside. And then whatever your denominator is what we call the index. That's going to go on the outside between the little V shape in your radical. Okay, and that's how you convert an exponential, a fractional exponent into a radical. Yeah, so it's a conversion, and you'll see like why it's useful throughout. But yeah. So this one here, you want to first make your exponents positive, and as you all know, to make an exponent positive, you have to bring it down to the denominator. Okay, step one. Then we're going to now rewrite it as a radical. So to rewrite it as a radical, you draw your radical symbol. It's y to the fourth power. The numerator is the power. The denominator is the index on the root. All right. Letter C. Now, if a number or letter doesn't have an exponent, what is the implied exponent? 1. So this is going to be a to the 1/5 power if you're converting it back to a fractional exponent. Any questions so far? Now another thing I want to mention, it doesn't come up yet, but it will. If you don't have an index, the implied index is 2, square root. Square is for 2, okay? All right. We're going to convert this one into a fractional exponent. It's going to be b to the 3/5. This one here is like a two-step problem. We're going to convert what's inside the parentheses first. So that's going to be c to the 1/4 power. Okay, the 1 over the 4. And then power to power rule says you multiply the powers. So 1/4 times 3 is just 3/4. Okay. Step 1 on this one is to make that exponent positive by bringing it down to the denominator. And then we can convert it into a radical. It's going to be the third root, that's how you say that, the third root of 64. Do I need to put that one exponent there? No. But here's the thing. 64 is actually a perfect cube root. Because what number can I multiply together 3 times that gives me 64? 4. So what's my final answer on this one actually? 1/4. Good. Okay.
If you didn't simplify it to 1/4, would you be marked wrong?
It would be probably partial credit.
Okay.
All right. Unless multiple choice, of course. Yeah. So, now we're going to simplify some of these expressions. So in order to simplify expressions with the roots, you always need to convert it into a fractional exponent first before you simplify, so that's what we're going to do. So like I said, the implied index, that's the little number on the outside of the root, is always 2 when there's not one given to you. So this is going to be x to the 3/2 over x to the 2/3. Now, does anyone remember what we can do when we have the same base with different exponents and we're dividing? We can subtract the exponents. So we can do 3/2 minus 2/3, but we can't do this right away. We have to find a common denominator. So I'm going to multiply the top and bottom of this one by 3, and I'm going to multiply the top and bottom of this one by 2, which is going to give me 9/6 minus 4/6, which is actually what? 5/6.
Did you simplify that to?
It is fully simplified. 5/6 can't be any more simple.
Oh.
So then what you could do is you would write it as x to the power of 5/6. But that's not our final answer, because if you remember earlier we talked about your final answer needs to be in the form that the question was asked. And it wasn't asked as a fractional exponent, it was asked as a radical. So you have to go ahead and convert this back to radical form. Like that. And that would be your final answer. Okay?
Is it like ridiculous or something?
Oh, it's different. It's wrong. 1.0. Okay. Next one. So how could I convert the square root of y to a fractional exponent? It would be 1 over 2 times y to the 1 over 4. Remember, it's an implied exponent of 1. Now, when I multiply, what do I do with the exponents? Add them. Subtract when you divide, add when you multiply, right? So, I want to add these together.
Do we have that one or do I need that one?
What'd you say?
Would you have this one or?
Yeah.
Is this just one side?
Yeah, 1 point off only. Or is it both parts? Just 1 point. Thank you. Okay, so this one here is going to be converted into, we have to find a common denominator, of course, so I have to multiply top and bottom by 2. So I get 2/4 plus 1/4, which is what? 3/4. So we end up with y to the 3/4. Can I leave it in this format?
No.
No, I have to convert it back to a radical, right? So what is this going to be as a radical?
4 radical 9/3 y.
Very good. So your numerator goes inside, your denominator goes outside. Alright. This one here, are we going to add or subtract the exponents? Add them. So we want to add 2/3 plus 1/2. So once again, we're going to find a common denominator by multiplying top and bottom of the first one by 2, second one by 3. We get 4/6 plus 3/6, which gives me 7/6. So we get a to the 7/6. And this one we don't have to convert back because the question was asked as a fractional exponent. Alright, so here's some key vocabulary. As we go through, we're going to use this terminology, so I want to make sure you understand it. Power is exponent. Index is that little number on the outside, the type of root. Radicand is everything inside the radical. And the radical symbol, of course, is radical symbol. These are the first few perfect squares and perfect cubes. So this is like 1 to the second power, 2 to the second power, 3 to the second power, and so on. Okay? This is 1 to the third power, 2 to the third power, 3 to the third power, and so on. Okay? So there is a little bit of a rule that we have to be a little bit careful about. You cannot assume the nth root of a to the n is a, because there are some counter examples to that. I'll show you one right now. Right here, if this is the index, here is 2, right? So you would do, if you were to rewrite this as a fractional exponent, you would write it as -6 to the power of 2/2, which would be -6 to the first power, which would be -6. But that's not quite right, because if you had simplified this earlier and you done -6 to the second power, you would have got 36. The square root of 36 is 6, not -6. So this leads to a property that we have. It's a little bit of a rule that we have to deal with. So if your index is even and your result has an odd exponent, you have to put an absolute value around your variable. Okay? So I'll talk about how we do that. We're going to do some examples where we do that, and it will make a little more sense once you see it. But here are some examples of that. Alright, so we're going to go ahead and simplify these. So right here, is the index even or odd? Odd. So we don't have to worry about that rule at all. What number could I multiply together 3 times to get negative 8? Negative 2. So our answer is simply negative 2. Negative 2 times negative 2 times negative 2 is negative 8. Yes. Or negative 2. I don't know why I said that. Maybe I said it right? I don't know. So what is the square root of 4? 2. So this is an even index, okay? And this is an odd power. So technically you want to make sure you take the absolute value of that answer. In this case it doesn't matter, right? The answer happens to be 2. Okay, but had it been negative, it would have fixed our problem. Next one here. This one, this is an even index. Okay, now here's where you have to be a little bit careful about this one. This would be negative 4 to the power of 1/4. We can't actually really do anything to simplify that one. Okay, so we can just leave it that way. And then this one here, we have an even index, okay? So this could be rewritten as negative 2 to the power of 2 over 2. What is that going to simplify to be? Negative 2 to the 1, right? Which would be what if we had done it just right now? But that's not the correct answer because we should put what around these? The absolute value, because we started with an even index, we ended with an odd power. That's where you have to put the absolute value around our results, okay? So that's where you have to be a little bit more careful of it. Alright, yes?
So what's the rule with the odd value?
I think it makes more sense when you see it with the variables, but like the main rule is if you have an even index and your result has an odd power on it, you have to put an absolute value around the result. Okay. So we're going to use that rule here as we simplify these roots. Okay. So first thing I like to do is I like to break up my roots into the numerical portion times the variable portion. I just think it's easier to deal with. And then I want to break up my root in a way that I know I can simplify it. So what could I break up 18 into that gives me one of those being a perfect root?
9.
Yeah, so I can rewrite the square root of 18 as the square root of 9 times the square root of 2, right? What is the square root of 9? 3 times radical 2 times, so here's the easiest way to do this. What's the implied index on this root right here?
2.
So this is going to be x to the 8 over 2, right? Which is going to simplify to be x to the 4th. Okay. So I had an even index and I had an even result on my variable. So do I need to put absolute values there? No, only when it's even then odd. Okay. Alright, next one is a third root. So like I said, I like to separate the root of the numerical times the root of each of the individual variables. Yeah. What's up?
What's the rule we have with rounding?
Oh, within like one number, it's fine. Yeah. Yeah, thank you. I forgot to mention that. Okay. So, third root means that it needs to have the product of a perfect cube. So if you look at the numbers on your page, 1, 8, 27, are any of those numbers going to go into 54 evenly? 27. So can't I rewrite this as the third root of 2? What is happening? Times the third root of 27.
What's up with you?
shut the windows for these people.
Yes,
No, it feels
please
good
don't.
with the windows
I know, it
open.
feels so good.
Tell
It's
him
like
to shut up.
He'll stop.
I really wanna go outside to see
Just
my
scream out the
Oh.
windows.
Now I feel
actually
bad.
yes, he
what are they doing?
he's really excited.
He's so mean.
No. No, he's so
So annoying. Alright, anyways. So, what would be the cube root of 27? 3. So we've got 3, the third root of 2. And then we've got a to the 6 over 3. And then we've got b to the 8 over 3. Really don't make me shut my window, this
No,
guy.
please don't shut it.
Well, I will if we can't get through the lesson. I'll have
We
to.
can.
Alright, so from here we're going to end up with 3 times the third root of 2 times a to the second. And then b, we can't do anything with this, so we can just convert it right back to a root since it didn't simplify. So now we're just going to write it all out.
How did 6/8 turn into 2?
It's 6 over 3.
Oh, my bad.
No, that's okay. It's hard to see probably back there. So then this is going to be the third root of 2 times b to the 8th. And that's our final answer. Now with this question, do we have to worry about the absolute value rule? No, because we don't have an even index. Okay? Only if the index is even do we have to worry about that.
So if you have odd or even, it doesn't matter?
Yeah, it's even to odd, that's the only one you have to worry about. Alright, so for the next one, since they're all variables, I'm just going to rewrite them as, it's going to be x to the 8 over 4 times y to the 12 over 4, which is just going to become x to the second, y to the third. Now we have an even index, so if any of our results have an odd power, we have to put an absolute value around that variable. So which one of these do we have to put an absolute value around? The y. Good. So you always want to put that in at the very end. But the reason for that is if you get a result inside that y that comes out to be negative, you have to make sure you take the absolute value of it for it to work. Alright. Letter D. So we're going to see if we can simplify this. So, the easiest way to do this one would be to write it as a to the 12 over 2. Now the problem is, if I take the b out and put it the same way, what's going to happen is I'm not going to be able to simplify that, right? I'm going to get 15 over 2, which is going to be 7.5. So here's what we are going to do instead of that, okay? Can't we rewrite b as b to the 14th times b? So then we can now take out that b, so it's going to be a 12 over 2 times b 14 over 2, and then times the square root of b. Because I know the regular square root of b, that's just going to be to the 1/2, and I can't do anything to simplify that. So this is going to end up being a to the 6th, b to the 7th, and then you still have a b left in your root. Now, we took an even index, and did we get any odd results?
Yeah.
The b. Got to put an absolute value around it. Alright. This one here is going to end up just being x plus y to the 16 over 4, which simplifies and gives me 4. Now, you could multiply this out, or you could use Pascal's triangle if you wanted to multiply it out. We're not going to do that right now, though. So that would be our answer.
After using Pascal's triangle? So it could be, do you want the more simplified version, or is that okay?
Oh, you mean like you can no, this would be sufficient for this particular topic. Yeah. Do you have a question? Oh, okay. But I was saying, like, if you wanted to use Pascal's triangle, you could expand that binomial if you wanted to. Okay. This one here is really just the product of negative 1 times y minus 9 to the 9th power. So I'm going to rewrite it as the third root of negative 1 times the third root of y minus 9 to the 9th power. The third root of negative 1 is just negative 1, because negative 1 times negative 1 times negative 1 is negative 1. And then this is just going to simplify to be y minus 9 to the third power, because remember 9 divided by 3. So my final answer is just negative y minus 9 to the third power. And that's it. Any questions?